Here are the top 10 forbidden theories that changed the world. Number 10. Darwin's theory of evolution. Charles Darwin's groundbreaking work shook the foundations of society. When he published On the Origin of Species in 1859, he presented a radical idea that life on Earth had evolved over millions of years through a process called natural selection. This theory directly challenged the long-held religious belief that species were created independently by a higher power. Some people argue that the theory of evolution conflicts with their religious beliefs and should not be taught in schools. However, despite the backlash, Darwin's theory revolutionized our understanding of the natural world. It provided a scientific explanation for the diversity of life on Earth and laid the foundation for modern evolutionary biology. Today, the theory of evolution is widely accepted among the scientific community as the unifying principle of biology. It helps us understand the relationships between different species and provides insights into the origins of human life on Earth. Despite its widespread acceptance, the theory of evolution continues to be a controversial topic in some circles. Some people believe that it undermines traditional values and beliefs and should not be taught in schools. Number 9. The heliocentric system of Copernicus. When Nicolaus Copernicus published his heliocentric model of the solar system in 1543, he turned the scientific community on its head. His theory proposed that the Earth and other planets revolve around the Sun, challenging the long-held geocentric belief that the Earth was the center of the universe. This went against the teachings of the Catholic Church, which believed that the geocentric model aligned with biblical accounts of creation. As a result, Copernicus's work was met with resistance and criticism, but he was far from deterred. With the help of scientists like Galileo Galilei and Johannes Kepler, Copernicus's ideas gained traction. Despite the opposition from the Church, they continued to make observations and collect data that supported the heliocentric model. Eventually, the heliocentric model was widely accepted, and Copernicus's contributions to astronomy became a cornerstone of modern science. His theory revolutionized our understanding of the universe and paved the way for further exploration and discovery. Despite the opposition, Copernicus's contributions to astronomy are undeniable. His theory of heliocentrism is considered one of the most important scientific discoveries of all time, and he is remembered as a pioneer of modern astronomy. Number 8. The Big Bang Theory. The Big Bang Theory is one of the most widely accepted explanations for the origin of the universe. According to this theory, the universe began as a hot, dense singularity and expanded rapidly outward. However, when the Big Bang Theory was first proposed in the early 20th century, it was met with skepticism and criticism from some scientists. For example, Albert Einstein opposed the theory because it implied that the universe had a beginning, which contradicted his belief in a static and eternal universe. But despite the initial resistance, the Big Bang Theory has gained widespread support over the years. One of the key pieces of evidence that supports the Big Bang Theory is the discovery of cosmic microwave background radiation. This radiation was detected in 1964, and it is considered to be a remnant of the hot plasma that filled the early universe. Other evidence includes the abundance of light elements, such as hydrogen and helium, as well as the redshift of distant galaxies, which suggests that the universe is expanding. Over time, scientists have refined the Big Bang Theory and developed models that incorporate new discoveries and observations. For example, the theory of inflation, which proposes that the universe underwent a period of rapid expansion in the first few fractions of a second after the Big Bang. Despite its wide acceptance, the Big Bang Theory still faces some challenges. Number 7. The germ theory of disease. Before the 1800s, the medical community had little understanding of the causes of infectious diseases. The prevailing theory was that diseases were caused by an imbalance of fluids in the body or by exposure to bad air, or miasma. This led to ineffective treatments and a high mortality rate. Ignaz Semmelweis, an Austrian physician, challenged this conventional wisdom when he noticed that the incidence of puerperal fever, a deadly infection in women after childbirth, was much lower in clinics where medical students delivered babies with cadavers than in those where they worked with live patients. He concluded that the difference was due to the students' failure to wash their hands properly after handling cadavers. Semmelweis recommended that doctors wash their hands before delivering babies, but his advice was ignored and ridiculed by the medical establishment. It wasn't until Louis Pasteur and Robert Koch provided evidence that microorganisms cause disease that the germ theory was finally accepted. Once the germ theory was established, it led to major advances in medicine and public health, including the development of vaccines, antibiotics, and antiseptics, as well as improvements in sanitation and hygiene. Number 6. Plate tectonics. In 1912, a meteorologist named Alfred Wegener proposed a radical idea that the Earth's continents had once been joined together in a supercontinent called Pangaea and had slowly drifted apart over millions of years. He called this theory continental drift. At the time, the idea was rejected by the scientific community because Wegener could not provide a mechanism to explain how the massive land masses could move through the oceans. However, in the 1960s, new evidence emerged that provided the missing piece of the puzzle. The discovery of seafloor spreading, the process by which new ocean floor is formed at mid-ocean ridges and pushes old ocean floor away, like a conveyor belt, provided the force needed to move the continents. With this new evidence, plate tectonics emerged as a unifying theory that explained not only continental drift, but also the location of earthquakes and volcanoes. The theory of plate tectonics revolutionized the field of geology and provided a framework for understanding the Earth's dynamic processes. Number 5. Kant's Island Universes Theory. In the 18th century, most astronomers believed that the stars in the night sky were fixed points of light that were unchanging and eternal. This view was supported by the prevailing belief that the Earth was the center of the universe and that everything revolved around it. However, in 1755, German philosopher and astronomer Immanuel Kant challenged this conventional wisdom with his theory of island universes. Kant argued that the stars were not fixed, but rather suns just like our own, each surrounded by its own planets and moons. He suggested that the Earth was just one planet in a vast and infinite universe. This idea was highly controversial and was not widely accepted at the time. But Kant's ideas planted the seeds of doubt about the Earth's special place in the universe and paved the way for future discoveries. In 1925, American astronomer Edwin Hubble observed that galaxies were moving away from us, providing the first evidence that the universe was expanding. This discovery provided strong support for Kant's theory of island universes and revolutionized our understanding of the cosmos. Today, we know that there are billions of galaxies in the observable universe, each containing billions of stars and planets. Number 4. Einstein's Theory of Relativity. Albert Einstein's theory of relativity revolutionized our understanding of space, time, and gravity. Special relativity, published in 1905, showed that time and space are intertwined in a four-dimensional fabric called space-time. This theory also introduced the famous equation EMC, which demonstrates the equivalence of mass and energy. General relativity, published in 1915, extended special relativity to include gravity. Einstein proposed that gravity is not a force, but rather a curvature in spacetime caused by the presence of mass and energy. Despite its revolutionary nature, Einstein's theory of relativity was not immediately accepted. Some scientists, including prominent figures like Robert Millikan, rejected the theory's implications for the nature of space and time. They argued that the concept of spacetime was mathematically elegant but physically meaningless. However, the theory's supporters, including physicist Max Planck, recognized its significance and championed its acceptance. Over time, evidence for Einstein's theory mounted, and it became widely accepted within the scientific community. Today, the theory of relativity is considered one of the most successful and influential theories in the history of science. Number 3. Quantum mechanics. Quantum mechanics is a branch of physics that studies the behavior of matter and energy at the atomic and subatomic level. It's a highly complex and counterintuitive field that challenges our everyday understanding of the physical world. One of the most perplexing aspects of quantum mechanics is the concept of superposition, which states that a particle can exist in multiple states at once until it's observed. Another mind-bending concept is entanglement, which describes a situation in which two or more particles are linked together in such a way that they share the same fate regardless of the distance between them. These concepts are often summarized in the famous thought experiment known as Schrödinger's cat, which illustrates the paradoxical nature of quantum mechanics. Despite the strangeness of quantum mechanics, it's a highly successful theory that's been instrumental in advancing our understanding of the physical world. It's led to the development of technologies such as lasers, transistors, and magnetic resonance imaging, and it continues to shape research in areas such as quantum computing and cryptography. Number 2. Quantum computing. Quantum computing harnesses the principles of quantum mechanics to perform calculations and simulations that would be impossible for classical computers. Unlike traditional computers that use bits to represent either 0 or 1, quantum computers use qubits, which can exist in a state of superposition and entanglement to perform calculations. This allows quantum computers to perform certain tasks exponentially faster than classical computers. The potential applications of quantum computing are vast and include drug discovery, material science, and cryptography. However, building and controlling quantum computers is extremely difficult due to the fragility of quantum states and the need for precise control over qubits. Despite the challenges, significant progress has been made in recent years, and several companies and research institutions are racing to develop the first commercially viable quantum computer. The race to build a quantum computer highlights the growing importance of quantum mechanics and the potential impact it could have on various industries. Number 1. Handwashing prevents infection. In the mid-19th century, Ignaz Semmelweis, a Hungarian physician, noticed that the rate of infection and death among women giving birth at Vienna General Hospital was extremely high. He hypothesized that doctors were transferring harmful substances from autopsies to deliveries by not washing their hands in between. Despite overwhelming evidence supporting his theory, the medical establishment rejected his findings. Semmelweis was eventually driven out of the medical community and died believing that he had been vindicated. However, it wasn't until the germ theory of disease was established that Semmelweis's work was finally recognized. Today, handwashing is a fundamental part of infection control and is credited with saving countless lives. Despite the obvious benefits of handwashing, it wasn't always widely practiced. In the early 20th century, a campaign led by the American Journal of Nursing helped to promote handwashing among healthcare professionals. However, it wasn't until the 1980s that handwashing was mandated in hospitals. Today, handwashing is considered one of the most effective ways to prevent the spread of infection. If you've got any thought-provoking theories you'd like to share, drop them in the comments below.